This is Eric Olson's video homework number 8. So this is number 3. So there's two thin coaxial shells of radius 1 and 2, and there's a current going 1 in one way, and it's going the opposite way in the bigger one, and it's of length b. So we know that if the radius is less than r1, since the shell, there's no I enclosed, so there's no b field. If the radius is greater than r2, then the i's are going both direction cancel, so there's no field produced outside the shells. So if you look at what energy density is, it's a 1/2 b squared over mu naught. So that is equal to the amount of energy in the b field stored over the volume. So that quantity times the volume equals the energy. So basically, that energy the energy density times the area over, which you do an integral over the volume, is equal to the energy held in. So let's go all the way back over here where I have the rest of my work. So there's going to be a field generated in between R1 and R2. So that B field is equal to mu naught I over 2 pi R. So you know that because the energy density times the area, it needs to be integrated over the volume. So what you do is, it's integrated, it's over the volume, but it's really over the length because it's area times length equals volume. So energy equals 1/2, which comes from up here, 1/2 b squared over mu naught. So that's 1/2. I took the 1/2 out immediately, so it's integral from 0 to b of mu naught over I, which is this right here, squared, and that should be over mu naught, so I just multiplied it by 1 over I naught, and then times the area, and then it's changing from d to dB. So 1/2 squared everything in there and started canceling things. You know the area is going to be pi r squared at any given time. So that pi is cancels with one of those pi's, and r squared cancels with that r squared. This mu naught cancels one of those mu naughts. So then you can move things down. You're taking a 1/4 out of that, so it's 1/8 times I squared, which you're taking out because it's not changing as b changes. And there's 1 pi left, and you can take that out. So it's the integral from 0 to b of dB, so that's just the integral of, that's just b evaluated from b to 0. So since the only value it could be is b, since 0, 0, and make everything 0, you just get b. So the energy stored in between these shells is 1/8 I squared b over pi.